that brings some international experiences to this nice conference, which is international by nature. So this is one of the interesting things of this conference, that we are learning not only about the developments in Spain, but the developments in other parts of the world. And this session is particularly dedicated to this issue. How high-speed train has been developed, which technical problems, which technical solutions, which technical good lessons we can learn from other experiences. And in that case, we have three interesting presentations from three different and far away from here countries. The first one is from Saudi Arabia, and this is very well known for Spanish people because many Spanish companies have been involved in the construction of this line, La Mecca-Medina railway line. And then we have with us Mr. Denis Dusso. He is an engineer specialized in signalization. And this is related, the presentation is going to present is the problem for application of security measurements, RTMS level 2 of signaling for assuring the good running of the line. After that, I'm going to present the two other speakers, but I think, for the moment, Mr. Dusso, you have the floor.
Assalamu alaikum. Buenos días a todos. Good morning. Welcome, everybody. My name is Denis Dusso. I work as a signaling engineer for the Haramain project in Saudi Arabia. Me llamo Denis Dusso, soy ingeniero de señalamiento y trabajo por el proyecto Haramain en Arabia Saudí. Estoy muy orgulloso, muy honorado aquí de estar aquí por este congreso y muchas gracias a la Universidad de Castilla-La Mancha y en particular al profesor Jaime Tamarit por esta invitación. Vamos a empezar con este proyecto desde el AVE del Desierto. Es un proyecto que se hace en Arabia Saudí, ¿sabes? Para conectar las dos ciudades más importantes del Islam, están Medina y Mecca. And in this case, so I would speak in Spanish and English both as well. And as you know, that Spain is exporting high-speed lines in Saudi Arabia, is called AVE del Desierto. So yesterday we have seen the line Madrid-Sevilla for 25 years ago, and now we can start with some similarities between the line that we have here in Spain, Madrid-Sevilla, and the line that we have in Saudi Arabia, Medina-Mecca. As you know, from Madrid to Sevilla via Ciudad Real, Portellano, Córdoba y Sevilla. In Arabia Saudi se empieza en Medina, and then CAEC, King Abdullah Economic City, is a new city. They're not so far away from Jeddah. Then there is the airport of Jeddah, King Abdullah International Airport. Then is Jeddah, and then the last station is then the holy city of Mecca. Let's have a look of the features of this line. So we have 471 kilometers for the Madrid-Sevilla, standard European gauge, and max speed 300 kilometers per hour, 25 kilovolts, 5 stations. We have quite similar condition for Haramain line, where we have a bit less, only 449 kilometers, standard gauge as well, maximum speed 320 kilometers per hour, 25 kilovolt for the electrification, as well as we have 5 stations there. Now let's have a look of the key figures of this line. There is a consortium of 12 Spanish enterprises. Is ADIF, Cobra, Consultrans, Copasa, Siemens. So they start with Dimetronic, but in the last years there was a change, and now it's Siemens, and in the future will be Siemens Alstom. Is the news from the last 2 weeks. And then also Imacia, Inabensa, Indra, Ineco, OHL, Renfe, Italgo. Is a contract of 6.7 thousand million euros, so 6.7 billion euros, to supply both railway system as well as rolling stocks. And there will be 35 Talgo trains, Talgo 350, for a speed of 320 km per hour maximum, based on Renfe Talgo Bombardier trains with 25 kilovolt element power. And Renfe and ADIF will operate for the first 12 years, this line. Maximum 160,000 passengers per day, and in 2.5 hours will be the normal connection when everything will be ready between Medina and Mecca. And signaling, this is the core of this presentation, is based on ERTMS level 2, based on baseline 230D. And now I'm going to explain you something more about this European technology. So ERTMS is an abbreviation that means European Railway Traffic Management System, and is a major industrial project being implemented in Europe to serve to a safer and also more competitive railway. The fundamental objective of ERTMS is to develop a single, harmonized, and fully interoperable control, command, and signal and communication system. And maybe sometimes you have heard about ERTMS and ETCS. Sometimes they are used as synonyms, but we can say officially ERTMS is based on ETCS, European Train Control System, plus GSMR. GSMR is the way that you use to transmit the information. It's like mobile phone, we'll say. It's a specific application of GSM for the railway field. And we have especially for level 2 and level 3, we are going to see later on. But in any case, ERTMS is made by ETCS and GSMR. And interoperability and compatibility are collective European problems requiring the collaboration among member states, enterprises, operators, suppliers, and so on. And it is a strong collaboration is necessary in order to achieve this. And for this, there are many working groups, especially the EIG ERTMS working group in Brussels, that are working for this in the last 15 years, even more. Why ERTMS? Why? As you can see, in Europe, we have many national systems that are not interoperable with each other. What does it mean? That when you are, for example, in Germany, we use PCB, LZB, or PZB, for example. There is not, it's not working in France or in Belgium, for example. For this reason, normally at the border, we have to either to change the train or to use multi-system trains, like the Thalys, for example. They're very complicated, very costly, and difficult to maintain, and so on. For this reason, so they develop a common system that is interoperable. What does it mean? We have some European corridors, like, for example, from Rotterdam to Genoa. We can start in Rotterdam and arrive in Genoa with the same train, with only one signaling system, ERTMS. There are also, in ERTMS, many levels of possible implementation. We start with the first one, the basic one, is ERTMS level 1. In this case, we place some balises that are connected. They are the transporter, as you can see here. They are connected along the track. They are sending some information. They are connected with the signals, and the driver has to always to look at the signal and respect the information that is going to receive from these balises. This is the first level of implementation. It's quite cheap, I would say, and brings some advantages, but not so many. The main advantages that we can get with ERTMS is the use of ERTMS level 2. In this case, we rely on the infrastructure, so we need, for example, GSMR, we need mobile communication in order to exchange information between trackside, the interlocking, basically the radio block center, and the train via GSMR. It's like sending SMS or messages. And there is a continuous dialogue between trackside, so the interlocking radio block center, and the train. As you can see, the RBC, radio block center, is the trackside component, is this one, radio block center. Send movement authority is a command for the trains, how far is the train allowed to travel, and which speed, and so on. And also sending the track description. And the train answers with his position. The trains reads the balises that are placed along the track, sending this information, and with his odometry can update and send his position every second. There is many messages sent RBC to the train, and the train answers with these messages. And this is the technology that we use for the Haramain project. In Saudi Arabia, we use ERTMS level 2. For this reason, we have 10 RBCs connected to 13 interlockings, and we are using GSMR. This is what we are doing now in the Haramain project, and also in some ERTMS line here in Spain, in other countries of Europe as well. This is now currently the application, the best application that we have of ERTMS, level 2. There are also some evolution, and yesterday, 2 days ago, we had some presentation about level 3. Level 3 is the future of ERTMS, using, for example, satellite technologies like Galileo, because with level 3, we spare the component track size, so we have just the balises, but then there are some issues, like, for example, the train integrity should be solved by the train. So that means the train should communicate not only its position, as well as if the train is completed, nothing has been lost along the track. For this reason, we need particular devices in order to assure that the train is still entire, I would say. And also, we don't have track circuit, so that means the localization of the train is made only by the train itself. There are some projects, some research projects at many universities and also in UNISIC level, as well as in order in the future to go to level 3. This is the future, level 3. Now we have a look back to Saudi Arabia. Saudi Arabia has a long tradition with railways that started more than 100 years ago, with the Hejaz Railway for connecting Damascus with Medina in 1912 and 1914. And you can see today in Madan Saleh, not so far away from Medina, there is still an old station. And you can see as well an old train that was used in Saudi Arabia 100 years ago. What they start, and then they stopped due to the First World War, then the line was stopped. Maybe you have seen the movie Lawrence of Arabia, and it was about this line. And now what they started 100 years ago, they're now to continue, because ideally this line should connect Damascus with Mecca, but they never reach Mecca, they reach just Medina. And now, with the Haramain project, that you can see a picture that I took a few weeks ago, you can see what they're doing. Here, there's an element that I showed you before for ERTMS, the balises. Balises here are placed along the track for sending the position report. The balises send, when the train is running on the balises, there is an antenna sending a telegram. And in this telegram, there is the position of the trains. So that means the trains knows where it is. As well as you can see the Talgo trains that are there. The color here, you cannot see very well, but is the color of these stripes is green, because it's the color of Islam, like the flag of Saudi Arabia. That is the same color, basically. Well, I think that you have to be very proud of what the Spanish enterprises are doing now in Saudi Arabia. They are exporting the Spanish technologies, contributing to the economy of this country. It is a very important project. The experience gained here in the last 25 years. Now, Saudi Arabia can gain for this, and they can, because Saudi Arabia, they wanted the proven technology, and now ERTMS level 2 in Spain is a proven technology, ready to be exported. And now this is very important for Spain and for Europe. Now we are going to the end of this year, and now my question is for you if you have tienes planes para Nochevieja. ¿Por qué? Here in Spain, normally you eat grapefruit the last day of December. Usted tiene aquí esta tradición de comer la uva el último día del año, pero este año no va a pasar. No para todos, no para todos. ¿Por qué? So this year, this tradition, not for everybody will happen. El AVE español a la Meca comenzará a circular este mismo año, porque the service demonstration of the Haramain project will start on the 31st of December of this year. Not everything is ready 100%, so that means it's not the maximum performance, but they plan to start the last day of this year, and it's a very important achievement that will be that for the Spanish enterprises working there. And I invite you on that day to think about your colleagues, the Spanish employees that are working on that project on that day. So you are going to eat your grapefruit, and there are 12, And you can think about that in Haramain projects, there are 13 interlockings and 10 RBC. Every one, 2, 3, it could be one interlocking. So you'll be connected with the people working there for the start of this Haramain project. Shukran. That means muchas gracias a usted. Thank you. Y que el proyecto tenga suerte.